So I hope you're all doing well. My name is Gabriel Isaacman Van Wertz. I'm a professor in civil environmental engineering. I've been here 4 or 5 years now. And what I study is atmospheric chemistry. So I'll show you a short little video. It's really short um, of just what my lab looks like and talks a little bit about what I do. And then I'm happy to answer any questions or chat with you about it. So let me go ahead and just play this. It's like 3 or 4 minutes long. It just shows you a little bit about. It shows you my lab. So I recorded it just earlier this week, so you can get an idea of what that actually looks like. Hi, I'm Gabriel Isaacman Van Wertz. Welcome to the Atmospheric Chemistry Lab on the 4th floor of Durham Hall. Our lab is focused on understanding where air pollution comes from and how it changes in the atmosphere and where it ends up. And we do a mixture of laboratory experiments here in the lab, a lot of measurements at field sites, which of course I can't show you pictures of here, but we'll show you some pictures in our webinar, as well as a lot of instrument development. A big focus of our lab is trying to understand how to measure what's in the atmosphere better, and how to validate the tools, and how to build better tools. So a lot of what happens in this lab is instrument development, and that ranges from sort of small, simple instruments up to much more complex ones. So I'll just give you a little bit of a tour of some of the things that are going on in the lab right now. A lot of the projects in our lab are focused on new versions of what's called gas chromatography and mass spectrometry. And so what's going on in this center table is development of a new instrument based on that technique. So the idea is that you have an oven that looks something like this, which I can open up for you. It says 300 degrees Celsius, which it is not, fortunately, at the moment. So it's just sort of a standard oven. And inside that, there are long coils of very, very, very skinny, very thin tubes, although it looks like a piece of glass. It's actually a very, very long, skinny glass tube. And you put something into that tube, and as it passes through the oven, it gets separated out into all of the things that are inside of it, or all of the different components of that mixture, and we use that to figure out where air pollution is coming from, and where it's going, and what's actually in there. And then it connects to instrumentation like this that's called a mass spectrometer, where we can actually tell what all of the different mixtures, or all of the different components of that mixture are. So you can see there's a couple of sort of development projects going on. Over here is a bit of a mess of wires and tubing. This is sort of a wholly new instrument that we're trying to understand how to measure what's in particles in the atmosphere easier and cheaper and better, so they can be regulated better. And you can see it's really in kind of the early stages of prototype development, and so there's not even really a box that goes all around it, just a lot of things connected together that we're trying to understand how they interact. So that's sort of one of the mid-range kinds of instruments we develop. We also do a lot of sort of high-end or state-of-the-art scientific instrument development that really is sort of more complex and is used more at the sort of research level. So this is actually an instrument that seeks to do something similar. It basically looks at everything that's in the particles in the atmosphere and sort of tells us what's inside those particles, and we can use that to figure out where they're coming from. And this is actually an instrument that we designed and built in this lab. So this is actually a home-built instrument. I know it looks a little bit crazy. It's something that we put together, and some of our more complex instruments look like this, and then we get down to some more simple style things where we sort of design our own circuit boards and use microcontrollers like this, and sort of very simple, small valves and controllers to try to build smaller, more portable instrumentation. So we do a lot of instrument development in this lab. We usually do a lot of our measurements out in the real world at field sites, and I'll show you some pictures. But most of what goes on here is what I call hammer and wrench chemistry. We obviously do some mixing together of chemicals and standards and things like that. But a lot of what we're really doing is building new instruments and trying to build things so that we can measure them better and really understand what's going on in the atmosphere. So you can see a lot of what's going on is sort of new projects that are just under development and sort of underway, which is exciting. All right, awesome. As I said, our group also does a lot of field work, which is not particularly conducive to a tour of lab. We have sort of continued to do field work through the pandemic. So I can actually show you a couple of pictures of some of the field work that we've actually done in our group. Probably the main field work we have going on right now is we actually have a 40-meter tall measurement tower near Charlottesville. So that's that picture here on the right. It's actually a big walk-up tower, and we have instrumentation on that. And we've done field work sort of all around the state and around here. This is actually in my neighborhood, sampling spills of residential heating oil. We've tried flying little things on drones before. We're starting to pick that back up. And we have some other instrument development that we've been kind of deploying to various other labs around. So the first one is, what's the favorite project research topic that you've worked on? That's a really good question. Um, I guess it sort of changes a lot, but it's for better or worse. I feel like I'm always sort of excited about the next thing that I'm working on, but I'm also often excited about what I'm currently working on. So I think I'm often sort of thinking about where we sort of want to go from what we're currently working on. I think that the tower project we're doing right now is actually really neat. So that project is we're sort of trying to understand how basically all of the gases that get emitted from plants. So like the smell of pine trees and the smell of lemon and the smell of basically anything that smells is emitting some sort of a gas. Um, and once it's in the atmosphere, it gets transformed, and it gets changed, and it has all sorts of impacts on the atmosphere and on the ecosystem. And so that project is really trying to understand how plant emissions impact regional atmospheric chemistry. And it's really neat. It's a huge amount of data, and there's a lot of collaborators. We have ecologists and biologists, and we have this really neat, you know, measurement setup where we have this big tower, and we built, boxes hanging off the tower to measure things, and there's just a lot of data and a lot of interesting things coming out of it, and I've been really enjoying it. So I don't know this. I don't know that I have a good answer to what my favorite project is. Um, when I sit down myself to do research and not just with my students, a lot of what I do is trying to do almost data science questions. How do we analyze our data better? How can we get more information out of our instruments? How can we analyze our data faster because you generate a lot of it? And so I sort of personally have my own sort of side projects doing that. So uh, the neat thing I think about sort of atmospheric chemistry is that what I am interested in is what happens to gases and particles once they're in the air, and everything emits gases and particles. So we actually have a project this summer measuring how gypsy moth pheromones work as treatment for gypsy moths in an orchard. I'm not an entomologist. I have friends who are entomologists, and basically they want to measure pheromones in the air, and it's similar. It's a similar question to what I'm usually doing. It's a similar technical problem tackling a very different question. And so I think one of the things I've really enjoyed is that I've been able to look at oil spills at underground tanks, how trees interact with the atmosphere, how instrument development, how insects signal to each other. Just a lot of different things using the sort of technical skills that I've developed. The other question was, I'm an environmental engineering student. I wonder if I would get to work in this lab. Great. Yeah. I mean, we're in environmental engineering. I mean, the department is civil and environmental. I'm on the EWR side, environmental and water resources. Um, I love having undergrads working in the group. I love having grad students working in the group. So we have our group right now is about half a dozen people. Usually ramps up a little bit over the summer as undergraduates come in, and often some of them stick around for the school year and some of them don't have time. Do your project include students with co-op internships or fieldwork requirement? I guess I don't know what you mean by requirement. I don't. If that's a technical question? I mean, I have undergrads and grad students come in and do fieldwork. Um, I'm happy to have students uh, come in for credit. I'm happy to have students come in through programs that provide other internship opportunities. Like we use the Multicultural Academic Opportunities Program. We often have students coming from there that they have um, sort of programs developing grad school skills as well as just the actual research. Um,
happen to have students, we've had wage employee students, who just wanted to get their hands wet with research. Some of those projects include fieldwork. Some of them can include, the data science side of things. This new project that we're doing with the gypsy moths, a lot of it is development of these small little samplers. That's what was sitting on that desk, and actually I've been working on at home. So this is actually a circuit board that I designed and built for that sampler. Um, and so those it's really conducive to little not side projects, but smaller projects that would involve a student, going to a site on and off a few times over the summer, and that would be that. So it's conducive to a lot of field work, and a lot of undergrads have been involved in that field work, and obviously grad students have been involved in that field work as well. One statistic that I like to sort of cite at people um, when they're sort of thinking about air and water. So a lot of the department is focused on water, of course, and water engineering has been a focus of environmental engineering for a long, long time. But the statistic that I like to quote is that if you just sort of do the back of the envelope, um, you basically drink 4 or 5 pounds of water a day, ideally, but you breathe about 20 pounds of air. So even though you don't think as much about the air, you actually breathe in more air by mass than you drink water each day. So you should be thinking about what's in your air. So our field is really sort of interesting in the sort of diversity of education and background, and scientific background, in that atmospheric chemistry involves all sorts of different stuff. So there's chemists in it. Some of my friends have degrees in chemical engineering. My degree is actually in environmental science. Now I'm a professor in an engineering department. There's analytical chemists. There's data scientists. There's mechanical engineers, electrical engineers. So there's all sorts of people doing this. So my undergrad was chem. I was a chemist, uh, basically undergrad double major in chemistry and earth and environmental science. As I said, there's all sorts of sort of backgrounds in this field. So my interests are largely in kind of the chemistry side of things. I do a lot of analytical chemistry, but also have sort of found a niche in the field in terms of being interested in the data science side of things. So building things and testing electronics. But the goal of it is all to kind of understand the chemistry better. So we have actually students in our group who are really good chemists. We have students in our group who are data scientists. We have some who are sort of solidly engineer, and one who's very into the technical side of things. Do I have a preference in collecting data? That's a good question. I like that question. I think I prefer analyzing it, I guess, personally. Collecting data is fun, but it's also very frustrating. It can be a lot of slow, meticulous work, um, and troubleshooting and things like that. But it's so fun when you have it to like look at what's in there and play with it. I think my favorite part is actually analyzing data on the fly. It's when you're collecting data, you don't know exactly what you're going to see, and you're doing this preliminary analysis to like understand what you're looking at and make changes to your experimental setup and things like that. I think that's sort of the most exciting is when you're analyzing really new data, while you're still basically collecting. That's the most fun. So at the undergrad level, I mostly teach intro to environmental engineering, which historically has a strong water component. I try to balance it some genetic component. And then I teach a number of grad courses on specifically on atmospheric chemistry, atmospheric measurement, um, and designing low cost sensors, or using low cost sensors to design low cost instruments. I guess. You think it's possible to work from both air and water when graduates with a degree in environmental engineering? Absolutely. I think that the split between air and water in many ways is particularly true at the sort of academic level. Um, I mean, environmental engineering companies do work on both. I think it can depend a lot, and I think where you really end up working on both is sort of at that interface. So, for instance, the project we did on residential home heating oil, we were basically measuring. Right, it was we were sort of coming in behind where environmental engineering companies had come and removed and remediated sites. Um, and so in that sense, we were thinking like the guy I was on the project with was a hydrologist, so we were thinking of sort of how are things moving underground? What is the groundwater situation and the underground situation? And then how is that going to impact air quality within the home? And so I think that there's a lot of interest in that, like in the space of like what's called vapor intrusion, where subterranean, pollutants in the groundwater can be an air problem. Um, and so I think that it's true that environmental engineering has historically focused pretty heavily on water, but there is a lot of industry and um, federal and state measurements that happen in air as well, called fence line monitoring, where you see what pollutants are being emitted out of the industry, that kind of thing. But yeah, there's a lot of water. Is there a specific academic background that a student needs to be successful in stuff? Um, no, that's the short answer. As I said, there's people from a lot of backgrounds. I'm sort of fundamentally a chemist and environmental scientist. There's chemical engineers, there's environmental engineers, scientists, things like that. I think it depends a lot on what angle you're going to take. And I teach a few different classes, right? I mean, I do atmospheric chemistry. Fundamentally, you're going to need some chemistry. Um, but when I teach atmospheric, so when I've taught atmospheric chemistry and atmospheric measurement in the past, we've had students from like mining engineering who are really interested in particles in mines, and so much more on the physical side of things and don't know too much about the chemistry. There's portions of the class they struggle with, but they all do fine. Um, and then there's chemists who can't quite get there, really in-depth chemists who aren't good at the technical side of things. So there's just the field is a little bit of a jack of all trades, and so uh, I think just depending on where your interests are and your background really can dictate where you focus within the field. But it's not sort of necessary to have one or another depending on what you want to do. I'd say for a lot of my classes, some chemistry is going to be important, but that can come through a lot of paths. Through chemistry background, through chemical engineering, just chemistry classes, alongside a mechanical engineering degree. All right. Well, thank you all for coming. Thanks a lot for coming by. Have a great day.